Imagine discovering a planet so far away that even light needs more than 27,000 years to reach us. We have never photographed these worlds. We cannot see their clouds, their colors, or their surfaces. In most cases, astronomers found them because gravity briefly bent and magnified the light of a star behind them. Today, we are counting down 10 of the most distant confirmed planets listed in the NASA Exoplanet Archive. But there is one important detail: their distance estimates have large and overlapping margins of error. This ranking follows the central values currently listed in the archive, not an absolute cosmic finish line. Welcome to Peak Selects. We begin at number 10 and travel toward the crowded heart of the Milky Way. Number 10, OGLE 2018BLG1647LB. At number 10 is OGLE 2018BLG1647LB, located an estimated 25,700 light-years from Earth. This planet is thought to be a cold gas giant with about 97% of Jupiter's mass. Its host is extremely small, with an estimated mass of only 9% of the Sun. The planet's projected separation from that star is about 1.36 astronomical units, slightly greater than the distance between Earth and the Sun. It was discovered through gravitational microlensing. When a foreground star passes almost perfectly in front of a more distant star, its gravity acts like a natural lens. A planet orbiting the foreground star can add a brief, smaller distortion to the pattern. That temporary signal may be the only chance astronomers ever get to detect the system. Number 9, MOA 2020BLG135LB. Number 9 takes us to approximately 25,760 light-years. MOA 2020BLG135LB. Unlike most of the gas giants on this list, this planet has an estimated mass of about 11.3 Earths. Without a measured radius, we cannot say exactly what it looks like. It may be a massive rocky world, a mini Neptune, or an ice-rich planet with a thick atmosphere. It orbits a star with roughly 23% of the Sun's mass, at a projected separation of about 1.11 astronomical units. Around such a faint star, that would make it a very cold world. The fact that astronomers detected a planet this small from nearly 26,000 light-years away shows why microlensing is so useful. It can reveal distant planets that produce no visible light of their own. Number 8, KMT 2025BLG0481LB. At number 8 is KMT 2025BLG0481LB, with a central distance estimate of roughly 26,030 light-years. This is a gas giant with about 59% of Jupiter's mass. Its host star is a low-mass red dwarf, only around 22% as massive as the Sun. The planet's projected separation is about 2.18 astronomical units. The system was added to the Confirmed Planet Archive in 2026, making it one of the newest entries in this countdown. Its name is not designed to be memorable. KMT refers to KMT-net, a network of telescopes built to monitor dense star fields and catch microlensing events. The numbers identify the year and the specific brightening event in which the planet revealed itself. Number 7, KMT 2017BLG2331LB. Number 7 is KMT 2017BLG2331LB, approximately 26,190 light-years from Earth. Its estimated mass is about 54% of Jupiter's, or roughly 171 Earth masses. It orbits a star with around 40% of the Sun's mass, and the projected planet-star separation is close to 2.14 astronomical units. Nothing in the data tells us its actual color, cloud pattern, or weather. Any detailed image is an artist's interpretation. What the observations do tell us is that a substantial gas giant exists in a planetary system near the central region of our galaxy. In other words, giant planets are not limited to our quiet local neighborhood. They also form in the dense inner Milky Way. Number 6, OGLE 2008BLG092LB. At number 6 is OGLE 2008BLG092LB, around 26,420 light-years away. This world has an estimated mass of about 18% of Jupiter's, equivalent to roughly 57 Earths. That places it below Saturn in mass. What makes it stand out is its very wide projected separation, about 15 astronomical units from its host star. In our solar system, that position would lie between Saturn and Uranus. The host is estimated to have around 71% of the Sun's mass. Because the planet is so widely separated, it would receive very little energy and would probably be an extremely cold world. Its discovery demonstrates that microlensing can find not only distant planets, but also planets on wide orbits that are difficult to catch with the transit method. Number 5. OGLE 2016BLG1093LB. Number 5 is OGLE 2016BLG1093LB, with an estimated distance of 26,480 light-years. This planet has about 71% of Jupiter's mass and orbits a star roughly 46% as massive as the Sun. Its projected separation is approximately 2.13 astronomical units. Like the other worlds in this countdown, it was not found by watching it pass in front of its own star. Instead, researchers measured the unusual shape of a temporary microlensing event. From that signal, they modeled the mass ratio between the star and planet, their projected separation, and the likely distance of the system. It is an indirect method, but it allows astronomers to explore parts of the galaxy that ordinary planet searches rarely reach. Number 4. OGLE 2015BLG0051LB. At number 4 is OGLE 2015BLG0051LB, approximately 26,745 light-years from Earth. It is another gas giant, estimated at about 72% of Jupiter's mass. But its host star is tiny, only around 1/10 the mass of the Sun. The projected separation between them is roughly 0.73 astronomical units. That combination is striking. A Jupiter-class planet orbiting an extremely low-mass star. The planet-to-star mass ratio is far larger than the ratio between Jupiter and the Sun. Systems like this help researchers test how efficiently giant planets can form around small stars, where the original disks of gas and dust are expected to contain less material. Number 3. KMT 2021BLG1077LB. Number 3 is KMT 2021BLG1077LB, about 26,875 light-years away. It has an estimated mass of around 22% of Jupiter's, or nearly 70 Earth masses. Its host star has only 14% of the Sun's mass, and the planet's projected separation is about 1.26 astronomical units. But this planet is not alone. The same microlensing event revealed a second planet orbiting the same star. That makes KMT 2021BLG1077L one of the rare multiplanet systems detected by microlensing. Since both planets belong to the same system, they share the same estimated distance and are effectively tied in this countdown. Number 2. KMT 2021BLG1077LC. At number 2 is that companion world, KMT 2021BLG1077L. Circa its estimated mass is about 25% of Jupiter's, or approximately 79 Earth masses. Its projected separation from the host star is around 0.93 astronomical units, placing it somewhat closer to the star than Planet B. Together, these two cold giant planets orbit a star far smaller and dimmer than the Sun. Their discovery is especially valuable because microlensing events usually do not repeat. Astronomers had to extract the architecture of the system from one temporary alignment of distant stars. We may never observe the same lensing event again, but its brief signal was enough to reveal an entire two-planet system near the galactic center. Number 1. KMT 2024BLG0176LB. At number 1, based on the central distance values currently listed by NASA, is KMT 2024BLG0176LB. Approximately 27,200 light-years from Earth. The planet is estimated to have about 76% of Jupiter's mass. It orbits a star with only around 10% of the Sun's mass, at a projected separation of roughly 1.32 astronomical units. Its estimated distance is 8,340 parsecs, but the uncertainty is large, more than 1,000 parsecs in either direction. That means several planets in this list could trade places as models improve. So it is more accurate to call this the most distant planet by the archive's current central estimate, rather than a permanently settled record holder. Even with that limitation, the detection is remarkable. A small change in starlight allowed astronomers to infer the presence of a planet almost 27,000 light-years away, close to the heart of the Milky Way. These worlds are not detailed photographs. They are discoveries reconstructed from gravity, light, and mathematical models. Yet every one of them proves that planetary systems exist far beyond the small region of the galaxy we usually explore. Which of these distant worlds surprised you most? Subscribe to Peak Selects for more journeys across space, history, and the most extreme places in the universe. Thanks for watching.